I'll be sharing with you guys on the Internet of Things or IR 4.0, and also of how we can use favorite platform for the purpose of reading your data from remote. Just for your information, the way that a lot of companies have pronounced our company's name is slightly different, but the right way to pronounce it will be favorite. Favor IoT or favorite, not FAVORIOT or FAVORIOT. So that's the wrong way to pronounce it. But anyway, let me share with you the slides. We're talking today about the Internet of Things. And as you know, Internet of Things have been quite some time being defined since 1999. And we always say that the father of IoT is Kevin Ashton. He is the first one that coined the term Internet of Things. So of course, along the way, there's a lot of other scientific definition, different journals have defined Internet of Things in many ways. But of course, I think forget about all that scientific things, that we make it more simple for a lot of people to understand what exactly is Internet of Things. So this is one of the areas that I would like to share with you about what exactly is Internet of Things and how it can benefit us, and why do we need it now as compared, we have been talking about this since 1999. So this is year to 2021. So it's more than 21 years, right? So because, for example, if you take a look at Malaysia, we talk a lot about IoT. And we have been talking this in Malaysia since 2014. Okay, it has grown the interest. Now we are seeing that in 2021, and because a lot of these things have been hyped again by the term IR 4.0. So as you know that Industrial Revolution 4.0 is being hyped because the term industry forward. Malaysia have launched in the end of 2018 a framework called Industry Forward. It's meant to cater for the manufacturing sector. So utilizing the technologies of IR 4.0. So we take a look at that also. Why suddenly everyone is talking about IR 4.0. And early this year, we have been bombarded another word again, which is called My Digital. So as you can see, sometimes it goes backward instead of forward. We see that during the pandemic, the COVID-19, when everyone is working from home, suddenly we just cannot jump straight to IR 4.0. We realize that there is certain fundamental infrastructure is not there, which is the internet. So that's why we are talking about internet again, back to square one. So a lot of people don't have access to the internet. What more about the speed and all that, right? So it is important for a lot of organizations because we see that technology changes in every year, and new technologies will appear, and some of them will become obsolete overtaken by new technologies. Products will become obsolete too. So if the companies are unable to cope up with these new technologies, they will become obsolete. So you will see that only 90% of companies are still in existence today, if you look at the whole 50 years ago. So we don't want to become that kind of company. So if you want to survive in this era, the 21st century, we need to be very, very competitive. And we need to cope up with the amount of information, the amount of technologies that being come towards us. Yeah. So if you look at the technology cycles themselves, technology comes in many waves, and a lot of these waves, when they join together, become a big tsunami. One of the technology wave is the mobile technology. As you know, mobile technology have changes from the first generation, which is very analog, and then become digital, 2G, 3G, 4G, and now we in 5G. So every of these technology cycles, they last for about 10 years, and a new mobile network will appear. So a mobile technology will be peak, matured at the 5th year. So whenever there is is matured, for example, in 4G, when it's matured at 4G, a lot of people have been using that, and there is no more further enhancement on the whole system, you will see that the new generation will come in. So that's why we are seeing the 5G in many countries around the world. In 2020, they have started to deploy them. If you are launching it a little bit late, then we are a little bit 2 or 3 years down the road. So we have heard about how the government is going to push about 5G, for example, right? And they are putting up a special purpose vehicle for that purpose. So you will see that. So the moment that 5G is launched, it means that the standards have already stabilized and being utilized, and a lot of equipments are based on the 5G standards. So what's more, so then you are hearing a new generation that comes in that going to be worked on is the 6th generation network. So I won't talk about the 6th generation network, but it's already starting in many countries who are at the forefront of technologies. So while other people are still scrambling to deploy towers of 4G, other countries have already started their 6G research. So, let's take a look at why is it important? Because we are now in this era, what we call the revolution era. But you got to understand, revolution means it's a very disruptive, sudden change. So it's not evolution where we evolve slowly, gradual. So it should be an revolution, yes. So there are many definitions in terms of this industrial revolution. So Malaysia, WEF, in this certain country have different way of defining them. So for example, in the case like the traditional way, the one that we have seen a lot is about, in the era of 1780s, where industry 1.0 utilizing all that physical things, mechanization, steam engine. These are the days of utilizing the 1.0 thing, very mechanical. And then when we started to introduce electrical, then we have the way to produce a lot more mass production. So when electronics are being introduced, chipset, electronics, internet, online, database, we are industry 3.0. And now in the industry 4.0, where the cyber physical things, where the cyber world and the physical world, OT and the OT and the IT are being converged. So this is where a lot of this industry 4.0 is being defined, but it is meant in the manufacturing sector. But the way that fourth industrial revolution, it goes across the whole our life, the whole livelihood. So what we are seeing in that some countries also define differently. For example, in Japan, they centralize their focus to the human people, the people themselves, how they live. In 1.0, they say that when people are a hunting society, they just use physical arrow just to hunt animals and all that. And then the agricultural society, we are 2.0. And then when they started the industrial society, where everybody moved from rural to urban, we are the era of 3.0, the society 3.0. Society 4.0 is where it's about information society. Internet is very pervasive. The society 5.0 is where a super smart society where they use artificial intelligence, Internet of Things. So that's how they define society 1 and society 5. So sometimes we shouldn't be confused with these terms, right? So I have my own terms. So this is how I define it, because Industry 4.0 and Industrial Revolution 4.0 are two separate things. For me, Industry 4.0 is very much for the manufacturing sector, the one that we are talking about, industrial automation and all that. But Industrial Revolution 4.0 encompasses the whole span of sectors, from agriculture, healthcare, e-commerce, everything. So it's under 4.0. So if you take a look at 1.0, if your technology doesn't have any technology at all, you're using manual and physical things, we are the era 1.0, as you know that. And 2.0, we start to use electrical in our daily life. In 3.0, you're using online computer in our daily life. In 4.0, you have intelligence, AI, robotics, drones, IoT, big data analytics, machine learning, and all that. All these technologies comes in at 4.0. But then, where is Malaysia, for example? So we know that these are the technologies in that particular era. So if we are talking about the way that we cook, as simple as that. Then we can define that if you are still cooking using this utensil, fire and all that, you are still 1.0. You know, you remember the days we still cook at kampung. In the kampung is 1.0 way of cooking. In 2.0, you start to use electrical oven, you know. In 3.0, you might have a microwave oven, electronics, right? So you have a way to compute it, program it, yeah, 3.0. But are we in 4.0 of cooking, where you can do a 3D printing? That's 4.0. So the way that we cook, I can see that we are still 3.0, right? So the way that we teach, now in this era, still at one time, we are 1.0, you know, using whiteboard, blackboard, and all that. 2.0, you're still using OHP, transparency, plastic, and then you project it on the screen. In 3.0, where now we feel that, hey, during the pandemic world, working from home, study from home, we are 3.0. That's what we are doing now. But are we reaching the 4.0 of teaching? No, because in 4.0, the way that we teach, maybe you use augmented reality. We use artificial intelligence. We might have robot teachers, you know. So that's how the era of 4.0 is. Okay. So what if the way that we transact, okay, maybe the way that we transact is quite good. Last time we still use the physical money, and then we use a cash register to transact, you know. Then we use the online credit card for that purpose. Now maybe you use e-wallet and all that. So we are quite advanced in that era. So there are times we are still in 1.0 things that we're doing, and there are things that we're doing in 4.0. So overall, when the country take a look at the readiness assessment of the whole industry, not the whole, the manufacturing sector industry, we are still at 2 point something, 2.7, 2.5, and all that. So that's still very far. So how can we move forward, and what are the main challenges that we face now? So the reason being is that there are many challenges. I think let's take a look at one by one. First, people have that difficulty to understand why the need for us to move into these new technologies. Why should we embrace these new technologies? They don't understand how this technology can help them. The way that they think, the business model is still the old way of doing the business model, brick and mortar sort of thing. So you need to have physical shops. Now we are talking about online shops. You know, the way that we rethink our processes. Everyone feel that they have a need for them to sign documents. We should change our process where the documents can be reduced and everything can be approved online. And the way that the action, the change management in the organization, the way that they make decisions between different silos of department, you know, the culture in the organizations is a old way of thinking, so hierarchical, you know, and then we don't dare to do any pilots. You know, if pilots will help us in terms of identifying any problems. And of course, the main thing now is that we are having this lack of talents. We need to create, because new technologies comes in, the kind of syllabus that we have in the universities need to be revamped very fast, closely understanding what the industry really wants. So if IoT is being introduced in the university, what are the syllabus, the kind of subjects, the kind of experiments need to be done in the universities? Because the industry wants them to be ready when they go out. So we need to recruit this kind of people with the right hardware and software talents. Okay, but since IoT is quite complex, they combine these two worlds of engineering and computer, and also programming. So that's why it's very lacking in the industry nowadays. So when we talk about IoT, we make it simple. We have 4 components, but there are many ways of people identifying these layers of IoT or components of IoT. This is the first way. I'll share with you the different method of the different way of people think IoT. Yeah? So they slice this in 4 components. One, they will talk about sensors, actuators, and the things that you have been working just now. VISI have also presented you of how to your sensors. And from there, they need connectivity, the way that you send your data out. So most likely now, when the sensors are connected to your computer, you don't have wireless connectivity. It's directly through your computer. But then through USB, for example, yeah, or through any RS232 port or whatever, so it's a physical link. But what if your sensors is very far away? You need to collect the data. So now what you want to do is that if you want to use your application just now, the DEX software, to remotely access the data from remote, then you need to send the data out using wireless. So where does the data being sent to? It goes into the IoT middleware. So this is where the IoT middleware, we capture all the data that comes from the sensors, store it in a proper manner, and it will ease the implementation of your connecting and collecting the data. And then from there, you can extract the data out and you can create your own applications. That is a simple way of forming components. But then other people will also have different way. So one of the ways that normally they will look at is that because IoT is all about sensors, hardware to software. So we will always based on the 7 layers of SI. So in the universities or in the colleges, you must learn these 7 layers of SI to really understand how IoT will interact in between all these layers. It is very important. And I've been telling this many times that in all of your subjects, learn these 7 layers of SI. Because you will know that on the physical layer, you will learn all about the way that the sensor is going to be connected. You know, either it's using copper, fiber, wireless, and doesn't matter. And then you go to data link layer. You will see you use ZigBee, RFID, or you use Wi-Fi. So all different protocols. And then you go to network. Either you can use IP network, the transport and network, TCP, IP. And then you will go to session layer of how you exchange your session, making it online to talk to another node. And then the presentation layer, how you encapsulate your data to make sure that it's secured. And then the application layer. So this is basically the 7 layers of SI. So if you scan me, you can take a look. I have a notes, what I call the IoT notes, simplified in a way that in such a way that I made this into a diagram, drawing, so you can learn it more easily. Yeah, you can scan this. Okay. So other people, we also take a look at IoT in 3 layers, as simple as 3 layers. They say that they will look at perception layer, which only talk about the sensors of gathering all the data. And then they will have network layer, how they transmit the data. And then they have application layer of how to deliver the data presentation or insights to the user. Or people will take a look at 5-layer architecture. Perception, they will have another one, a layer of transport and processing. So processing is where the middleware is. And then they will have application. And finally, they have a new layer called business layer. This is where your business models comes in. So other people also define 7 layers of IoT. So layer 1 and layer 2, the things and the connectivity, which is at the edge of the network. And then they will have the cloud infrastructure, layer 3, where they will pass that into the big data analytics, where you do data ingestion, you collect the data analysis, you are doing reporting, machine learning, and all that. And then you have the business value layer, you have the applications, and then the people and the processors who will do that. Okay, so you make application out of that. So different people have different perspective, but I prefer the 4-layer concept. It's much simpler for you to understand. But here, sometimes if you want to understand the technical part, you take a look at the 7 layers of OSI. So the reason why a lot of people needs to have this IoT to be connected is simple. They just want to know that they want to monitor the assets, and they want to monitor the environment where the asset is. So for example, if you are the human as the asset is the people is the asset, they want to monitor the health of the people. So you have a wearable that measures your blood pressure, heart rate, and so on and so forth. Then if your transport is an asset, you want to know where the location of your transport is. So you put a GPS there. So if you have an asset of like a parking lot, you want to know where the parking lot available. So you put a sensors that detect the car on the parking lot. So if the goods, the goods that you order, you want to monitor and track it, and you want to even monitor the freshness of the fruits. So you must have sensors that being connected and measured in the logistic. Yeah? So then you will monitor them, the freshness of the food. So there are many ways. So either you monitor the asset itself, but you can also monitor the environment where the asset located. So why exactly do we need all these new technologies like IoT and so on, so on and so forth? So I would say that this is only for the 7 M's. You first take a look at the first M, manpower. The way that technology can help you either can increase productivity or can reduce manpower. Materials of how, just in time sort of thing. So you want to make sure that your warehouse can accommodate the goods inside there, that it can reach on time. Machine, you want to know the utilization of the machine, whether it's fully utilized or underutilized. Methods, you can reduce your methods by having online measurement, remote metering, and all that. So you can reduce a lot of this manual sort of thing. So market, you can have access. The way that you design things cannot access not only for local market, but you can also export to international. Money, it creates new revenue stream. The way that you can create new projects, new products, and you can create new revenue streams, and you can save costs, And management, of course, with all the data that they collected from all the sensors, now the management have a better way for them to understand and make decisions, because the sources of data can come from many places. Yeah. So this is what I call the 7 M of the business. So why do we need to collect the data? We also need, other than collecting the data, we have got to know that this data also have different ownership. So when you started to build your own data, you need to ensure that your customer can own the data, or someone else can own the data, or you can share the data. Yeah? So you need to know whether the data is meant for personal that you cannot share, or you make it private, it's only for certain organizations, or you want to make it public, you can make it shareable, or you can make commercial, you can sell or buy new data. Yeah? So the data can come in many forms, like people say data is the new currency, data is oil, but data is like black oil. The higher that you can process, the more that the data can be processed, it can make meaning, then people will pay more for that. So you can collect the bits and the bytes, the numbers is now, with all the data acquisitions, the bits and the bytes, but then it doesn't make meaning. If you cannot answer the questions of who, what, where, and when, so it cannot become information. But if you can answer the question of how, it become knowledge. When it can answer the questions of why, it can become understanding. So the higher you go up to the whole value chain, the more valuable the information is. Yeah? The more that you can translate it. That's why when you go up to the whole value chain, you use technologies, algorithms like machine learning, deep learning to do that. Yeah. So data can come from many places and many sources. And so, but if the data comes in silos, the problem is that you cannot make full understanding, because you can make better understanding if you can blend the data together and can create new applications. I give an example. You can have home applications that can tell you that when you're at home, when you fall down, for example. So if it doesn't connect to a health center or the hospital, it cannot activate or give alert to the hospital officials to come and take you, because you fall down. So you need to get help, emergency. So it's useless. So you cannot just hand poke. For example, like waste and transport. So you might have waste a lot, and you want the actual smart waste management, the lorry that can, the garbage truck that will know where exactly the garbage needs to be picked up, So you cannot go just to one place and the garbage, there is no garbage. So it's a waste of transportation, fuel, and also the cost and all that. So if you can blend data from many sources, you can build sensors for each verticals, and you can collect that onto a single platform, and that's where it makes meaning better. So this is where, like, the IoT platform that I mentioned to you is very important. A platform that connects multiple sensors. Different sensors comes in different protocols, different connectivity. So you need to make it easy for developers to create applications. Yeah. So that's why when we design the favorite IoT middleware, we wish to help this. We want to ensure that people can easily onboarding their sensors. So you can collect data easily. Yeah. Our model is that we call ourselves as platform as a service. If you look at the traditional way of doing on-premise services, because everyone wants to control everything, they build everything, they manage everything. So from the infrastructure, the networking, storage, server, middleware, data applications, they own everything. But sometimes they don't have the whole expertise and they outsource it to other people. Then when they don't want to have all this infrastructure to be built and maintained by themselves, they outsource this to the vendor. The virtualization, the storage, the servers, networking, all being outsourced to vendor. So it becomes infrastructure as a service. So you only manage the applications, the data, and the middleware. But like us, we allow you to create your own applications. We allow you to own your own data, but the rest, we will manage it for you. So you don't have to think where you want to park your device, your server, how you want to manage the infrastructure, manage the way that security and all that. So we will take away all this complexity from you, and you will only manage your applications and data, right? Otherwise, you can have that's another one, software as a service. Everything is built for you, just like Google Mail and all that. So what we are seeing now is that if some of you are in the universities, I can see there's a lot of issues when the students are trying to learn IoT by themselves, not in a proper way, and they will build their applications, but you will allow them to choose whatever things out there to create. And they have only 2 semesters. 1 semester for them may be too short time for them to build the solution yet, just to understand what's out there, to do a literature review, understanding what are the technologies, and then only the 2nd semester they try to build the solutions. So if you can have a proper lab which can test out and learn the whole components as mentioned to you, the 4 components of IoT, from the sensors, connectivity, middleware, and also the applications, then you have a complete IoT lab. A lot of times I see the universities and the labs in the universities are incomplete because they don't have that middle portion, the middleware portion. They have the Arduino sensors and all that. They will connect to a Bluetooth to the app. That's it. They don't have a proper middleware. But because when you go out, the real implementation is that you must have all the whole component, the 4 main components. So you allow the students to do their own research, to choose whatever platform out there. So they become confused which one to choose. Yeah. So that takes them a lot of times. So we want to standardize that. And because of that, they cannot complete on time because they are busy to build everything, the whole 4 main components. So if the engineering students are focusing on the hardware, why can't you allow them to build and create their own hardware design, new sensors, better quality, cheaper product, and all that? You can design that. And then in the computer science part, where they focus on data, they focus on analytics, then you don't have ask them to build the middleware part to collect the data and all that. So in the middle, we reduce that time frame by taking away that complexity away from you, focus on the hardware, focus on the analytics, and make it easy for you to collect the data. Yeah. So otherwise, they're so busy of connecting the data, putting on the dashboard. So there's a lot of times people wants to create their own dashboard. It takes a long time. So by the end of the day, the project just finished with a very simple dashboard. You can't have a very complete objective. And another thing is that we want them to continuously upgrade the previous projects by the students. So the data that being collected, sometimes being owned by the student, and that's it. So if the university own the data, they own the account, you can continuously give this account to the new user that can continuously upgrade the software and collect the same data, and they can continuously upgrade their products, their projects into a better system. So not to say that every every year you need to refresh new projects. So it takes a long time. Okay. So this is how it looks like. So it sits in the cloud. It's not the cloud. The middleware is a piece of software, that we have built, and we place that into the as I mentioned just now here. So the middleware, right, in this middleware. So the middleware is what we build. The rest is we don't build. It sits on the cloud. So now the cloud is, we have moved the cloud from US now to Singapore. But it doesn't matter. The cloud can be in Malaysia, in your place, or it doesn't matter if you want to host the infrastructure. So it has the ability of API. We have an API that can make you easily to connect it with different kind of connectivity or messaging protocols. You can have co-app, you can have REST, you can have MQTT, because different devices might have different requirements. So for smart city, you might have multiple devices with different protocols. So onboarding might be very easy. So from there, you can do, we can help you in terms of managing the data, because we have created a very hierarchical way of managing your project, from projects to applications, from applications to groups, from groups to devices and all that. And then you can collect the data. So the data can be either displayed on our own dashboard, or you can create your own dashboard by extracting the data out. Yeah. So this is what we want to do. We want to ensure that we can have a very simple way and easy way for you guys to create your own applications. Yeah. The notification engine, we have email, we have SMS, we also have Telegram if you upgrade to a paid version. So we have a free subscription where a lot of people have been using this too. Okay. So there are other key features. You can see that in the very user-friendly dashboard. You can easily see your data that goes in and out from the middleware. You can see the data that being generated from your sensors, the stream of data, whether you know that the sensors are alive, and you can see on your own dashboard. Yeah. So you can put, there's a map, you can put where, do the location, or put the location of your sensors in the map. We have a lot of tutorials or documentations. You can choose your own way of programming. Either you use Python, JavaScript, Java, it doesn't matter to us, because that is your applications. But we supported that. We supported Raspberry Pi, Arduino, and then we have currently with the new device with our Arduino colleague, the Hibiscus Sense. So we work with them. So we would like to encourage this usage of the platform to many users. So a lot of students nowadays, since we have launched this about 4 years ago, we have a lot of local universities and also overseas universities to use this for their projects, final year projects. A lot of students have done that. And these some of the customers, which is from the commercial part also, have been utilizing the platform either for commercial and also for trial purposes. So these are some sample applications that you can build. As I mentioned to you just now, you can do what measure water quality, water level, weather. This is all about environmental monitoring. Yeah. And then we can also do for indoor ambient temperature in your either warehouse, your data center, or you can do for smart parking for measuring the parking utilization, and also noise and pollution, asset monitoring, power monitoring, and smart manufacturing factory that can monitor their utilization of their equipment and so on and so forth. So we take the ease of we allow you to easily ensuring that you don't have to think so much about putting up the whole infrastructure, and it's very affordable. So how do we start? This is my last slide. So how we start the whole project? The easiest part is that if you can define and develop a small and focused solution that can have an immediate impact, then you have a buy-in. The moment you have the buy-in, you can do the next step. Where you can integrate to your current backend system. So once you have collected to your backend system, then you can create new workflow, and maybe you can create new business model and better analytics.